Hi, so in this video we're going to be looking at solving a GCSE question, and this one, believe it or not, is about Pythagoras' theorem, which it doesn't actually look like it's about Pythagoras' theorem to begin with, but as you start to go through the question you'll realise that it's definitely a big part of this question. So the first thing I want to draw your attention to is the fact that normally what students do when there's a shape in the question is that they ignore a lot of the text around it, and it's important that you don't do that. You have to read the information that's given to you. So first of all here it tells you that ABCD is a trapezium, okay, so that's really important. It then asks you to calculate the length of the line AC. And lastly, it asks you to give your answer to 3 significant figures. Now, all of those points are the key parts of the question that you've really got to make sure you have clear in your head. Now, the length AC is not actually a length which is labelled on the diagram. So the first thing I would do is draw it in so you can see where it is. So if we draw the line AC in, we can actually see it's the diagonal of the shape, and more than that, it actually makes a right angled triangle. And there's your first clue that it's about Pythagoras' theorem. Okay. Now on a right angled triangle, you can use Pythagoras to calculate missing lengths, but only as long as you have 2 of the other sides. And in this case, if we look at the triangle ABC, we've actually only got the length AB, we don't have BC, and obviously AC is the one we want to find. So at the moment we don't have enough information to work out the rest of the question. Now I said to you it's important that we know the shape is a trapezium. The reason that's important is because on a trapezium, every trapezium has 1 pair of parallel sides, and that pair of parallel sides is the 2 lengths AB and DC. The reason we know that is because here and here we can see that these have been labelled as right angles, and therefore they must both be parallel to each other. So moving forward, what would be really helpful is if we knew the length BC, because then we'd have 2 sides and we'd be able to find that 3rd side AC. So we can't find BC as it stands at the moment, but if we add in another line going across from D parallel to BC, and if it's parallel then it has to have these right angles in again here, we actually form a little rectangle there. This side, if we label that point there X, then BCDX is a rectangle, and using our knowledge of rectangles, BC and XD are equal in length and are also parallel. Now, why does that help us? Well, it helps us because we can then look at this triangle here, AXD, okay? Now, I recommend that you actually, whenever you're doing a question like this, you draw out the triangle that you're trying to find. So in this case, we've got the triangle AXD, and label on the information that we have. So we know AD is 10 centimetres, and it looks like that's all we've got. But we have got some more information. AB is 9 centimetres and DC is 3 centimetres. And if that line is going all the way across there and perpendicular to these 2 sides, then it must mean that that is also 3 centimetres, which means that the bit left is actually 6 centimetres, because 3 plus 6 will give you 9. Importantly, in your GCSE questions, there'll always be a note to the side saying that diagrams are not drawn accurately. So you notice the scale of this doesn't quite look right, but you have to follow the maths and make sure that you use that information to make conclusions about the question. So now we have this, and we can find XD using Pythagoras' theorem. Now, if we work through Pythagoras' theorem, it states that the hypotenuse, which in this case is AD, the hypotenuse squared, and we can note that by the fact that it's the longest side, and you can always identify it because it's opposite the right angle. So AD squared is equal to AX squared plus XD squared. Okay, so for Pythagoras' theorem, hypotenuse squared is equal to the other two sides squared and added together. So if we fill in the information, AD squared is 10 squared, AX squared is 6 squared, and XD squared is what we want to find. That's 100, that's 36, and that's XD squared. Okay. What we then need to do is rearrange it, and when you're finding a shorter side using Pythagoras' theorem, you'll always find that you'll end up doing a subtraction. So this is just 100 take away 36, which is actually 64. Now if you know your square numbers, you'll know that 64 is 8 squared, and so therefore to find the square root of 64, it's just 8 centimetres. Now importantly, you might not have had to have done all of that working if you recognise something. So this triangle is what's known as a Pythagorean triple. And what a Pythagorean triple is, it's just a right angle triangle where all the sides are integer values. Okay, so there are a few that it'd be worth your while recognising. So one of them is the 3, 4, 5 triangle. Okay, so 3 squared plus 4 squared is equal to 5 squared. And in actual fact, if you just double all of those numbers, you get 6, 8, 10. And as you've just seen, 6 squared plus 8 squared is equal to 10 squared. Now there are others, and I would recommend you do a bit of research and find out a couple more of them, because as I said, if you recognise that, then straight away you could have just written down that XD is 8 centimetres. So now we know that XD is 8 centimetres, it means that BC is also 8 centimetres, because, as I stated earlier, this is now a rectangle, and using the conditions for a rectangle, those two lengths are the same. Okay, so now we can look at the triangle AXD, and again I would recommend drawing it out. Okay, so the triangle we're looking now at the triangle ABC. So triangle ABC looks like this. It's AC that we've been asked to find, okay, and AB we know is 9 centimetres, okay, and BC is 8 centimetres, all right, because that's the length that we have just calculated. So now we have enough information, and using the exact same technique we had here, we can now find the length AC. So, same as before, AC squared is the hypotenuse, it's opposite the right angle, it's the longest side, is equal to AB squared plus BC squared. Fill in the information, so AB squared is 9 squared, and BC squared is 8 squared. So AC squared is equal to that, and if you work that out, which you can do on your calculator or in your head, that works out to be 145. Now, if this was on a non-calculator paper, they might ask you to give your answer in surd form, in simplified surd form, but the clue is in the question. It says give your answer to 3 significant figures. Now that should tell you straight away you need to use your calculator. So you use the square root button on your calculator to find the square root of 145. Now if you do that, you'll find that it's 12.041 and so on, okay? And then the last part of the question, we've got to make sure we round correctly so we don't lose that final mark in the exam. So we've got to give our answer to 3 significant figures, so we count the digits, 1, 2, 3, there's our cut-off. You check the next digit. If it's 5 or higher, then this gets rounded up. If it's below 5, then it stays as it is. So finally, your answer is that AC is equal to 12.0 centimetres. And it is important to leave in the 0 and don't forget your units.